So starting with your warm-up today, you should have your pencils down, grading utensils out. So it said to evaluate each using the values given. So we're looking to replace our variables with the numbers they represent. So in number 1, it says y divided by 2 plus x. Well, we know y in this problem is 2. We know x is 1. So now that we've switched out the numbers for the variables for the numbers, it's a matter of PEMDAS, order of operations, which would say to divide first. So I would have 1 plus 1, which is 2. Going over to number 2, same concept, replacing our variables. This time we have a and b. A is a positive 10, minus 5, minus b, which is 4. Well, it's all subtraction, so we just go from left to right. 10 minus 5 is 5, and then 5 minus 4 tells us 1. Number 3, we have an exponent here. So we have 5 squared plus m, and m is 1. Well, 5 squared is 25. 25 plus 1 should be 26. Last warm-up, hopefully you're 100% right now. We have y plus 9 minus x. X is 1 and y is 3. So 3 plus 9 minus 1. Order of operations when we have addition and subtraction, say to go from left to right. 3 plus 9 is 12. 12 minus 1 is 11. Make sure you've been grading your warm-up, correcting it as needed. Checking your answers from worksheet practice C. Make sure on number 2, number 3, number 4, number 6, and 8, all those started with the minus in between, which means you had to distribute the negative and change all of those middle signs, all those other signs, to the opposite. These got a little bit bigger. We had some more variables and exponents. Remember, it does not matter the order at this point. We're going to talk about order today, but as long as if it's a positive, you have a plus sign, and if it's a negative, you have a minus sign. So check through these, ask each other's questions as you're going over them if there's any that you missed, and then unpause it when you're ready to move on. We're going to start identifying in detail our polynomials. Most of these words should be familiar to you from Algebra 1. The first thing we have is what we refer to as a monomial. Well, hopefully you're recognizing the first part of the word mono, which means 1. So our definition for monomial would be a real number a variable or a product of the two. The main thing with the monomial is they have to be pretty much connected. We can't see any plus signs, minus signs. We're looking for just one term. So some examples of that, a real number could be a number like -4. It could be positive. A variable, our most common one that we usually work with, is an x. It doesn't have to be. It could have an exponent with it. So maybe x to the 4th, or it's a number times a variable. So something like 2x, or maybe we'll just throw a different variable in there for fun, or 3y cubed. All of those are one term. They're connected together. There's no plus or minus sign, so they're in the monomial category. Our next vocab word is a polynomial. Poly, meaning many, so it's many monomials. It could just be one, but typically it's more than one. So monomial is a very specific type. Polynomial is more of a general category. So a polynomial is a monomial. Or sum, meaning adding. It could also mean subtracting because you can add the opposite. Or sum of monomials. One quick example of that, because we're going to see lots of examples of these, would be something like 2x squared plus 3x plus 1. These have plus signs in them. They could also, again, be minus signs, but it's connecting different monomials together. So we've got one monomial here, a second one here, a third one here, and they're being connected with either plus signs in this case or minus signs in other cases. The degree is the greatest exponent. And when we label polynomials, we do base it off of their highest exponent or their degree. So if we have this example, 3x plus 5x squared minus x to the 5th plus 2, it doesn't matter where in the problem that highest exponent is, wherever it is, that's still the highest one, and the highest one here is 5, so we would say that this degree is the 5th degree. Doesn't matter that it didn't come first, it is still the highest exponent. Now when we write these, we do base it off of your degrees, highest to lowest, and we'll get into that in a little minute. So even if it doesn't come first originally, the lead coefficient is the coefficient, which is the number attached, of the variable with the highest degree. So quickly doing another example here. If I had we'll just make this one up, 7x to the 6, actually no, sorry, 7x cubed plus 2x to the 6 minus x squared plus 8. So the first thing I would do is I would look where in the problem is the highest exponent. Well, here the highest exponent is a 6, so the lead coefficient is the number that's being multiplied by that because it technically should come first. That's the 2, so our lead coefficient, which you can actually abbreviate as LC, you will see that, equals 2. And again, it's not the fact that it doesn't come first originally, it's the fact that it's attached to their highest exponent. And now, if you look at our last vocab word here, before we get into that chart, which is standard form, this is how we write our expressions. We didn't use this yesterday because we hadn't learned it. You just wrote them in any order yesterday, but now we're going to start getting specific. Standard form is when we arrange terms by exponent. And we're talking about highest to lowest. So an example of that, if we take the problem from above that we did our lead coefficient of, since the lead coefficient was 2, because it had the highest exponent attached to it, that's the one that should then come first. So 2x squared, since it's positive, we don't need to put anything in front of it. I then look for my next highest exponent, which will be the x cubed, and it's positive, so we put a plus. Then I have an exponent of 2 minus x squared, and then plus 8. Numbers that are by themselves will always come last. There's something we refer to as a constant. Make sure you have all of your vocab written down before we move on to the chart. So here we're going to be describing our polynomials based on their degree and number of terms. The degree and the number of terms, they don't necessarily have to go hand in hand. They could be from any degree matched with any number of terms. Okay, but there's two names, one for the degree and one for the number of terms. If something has a degree of 0, that means it doesn't have an exponent, and we call that a constant because it's not going to change. And this typically is only when you have a number, and we'll go with the number 5. Now, looking at that, that's one term. And anytime we see just one term, which means there's no plus or minus signs, we're going to call that a monomial. Moving on to when we have a degree of 2, degree of 1. When I have a degree of 1, that means that if there was an exponent, it'd be a 1. We see that when we graph our linear equations, which we did back in Module 1. In order to be linear, you have to have a variable. It can't just be a constant. So we're going to call it the variable x. That has the highest exponent of 1. Any other exponent would be called something else. And we're going to say x plus 4 is our example here. Now looking at that, x is one term in itself. 4 is one term in itself. They're separated by a plus sign. So that means we have two terms this time. Well, this one we should know already. I've heard most of you use it and refer to it. Two terms is a binomial. So in this case, the name for it would be a linear binomial. Remember, two names for each of these. Well, the next exponent, the highest one, is a degree of 2. We've used this one already this year. This was in actually chapter 2. And when you have a degree of 2, that means your exponent is 2, and we call that a quadratic. Those are the parabolas or the U-shapes that we drew all back in chapter 2. So when you have a quadratic, then the highest exponent in the entire problem can only be a 2. So for example, 4x squared, and we'll say minus 2. Well, based on this example, highest exponent is 2, so that name is the quadratic. Well, the number of terms, I've got one term here, one term here. So that's a total of 2. And anytime we see 2 terms, we call that a binomial. Moving on to a degree of 3, well, if our exponent is 3, we call that a cubic. A cube is a 3-dimensional shape. So for whatever example we write, our highest exponent has to be a 3. So we're going to say 4x cubed minus 2x squared plus x. Well, now to identify how many terms we have there, so here's 1. It's separated by the minus sign, so now we've got a second term. And then we have a plus sign, which means we're also looking at a third term. So we have 3 terms here. Another name that you should be familiar with. If we have 3 terms, we call that a trinomial. So this one would be called a cubic trinomial, 2 names. One for the degree, one for the number of terms. A 4th degree, this is the one that a lot of students get confused with quadratic. They want to say quadratic is 4 because of that quad, but quadratic is 2. 4 we refer to as quartic. One way to remember that is it has the word quart in it, and there are 4 quarts to a gallon, 4 quarters to a dollar, anything like that. 4 quarters to a football game as well. Well, quartic means that no matter how many terms or how many exponents are in the problem, the highest one can only be a 4. So we'll say 2x to the 4th plus 5x squared. Well, based on this example, we have 1 term, 2 terms, and anytime we have 2 terms, we simply refer to that as a binomial. So this one would be called a quartic binomial for its degree and its number of terms. Our last one is a 5th degree. 5th. Our 5th degree is the last one that has a special name to it. And this one, if you have a set of 5 babies born at the same time, we call those quintuplets. I believe there was a Disney show called Quints. So this is a quintic. So in the entire expression, our highest exponent has to be a 5. So for example, something like 9x to the 5th. Well, since I didn't put any plus or minus signs with it, that takes us all the way back to 1 term. And again, anytime we have just 1 term, it's referred to as a monomial. Now, if we have more than 3 terms, because we've seen 1, 2, and 3 being labeled, anything more than 3, such as 4 terms or 5 terms, or etc., then it no longer has a special name, and they're just referred to as a polynomial. Again, poly meaning many. If we have more than an exponent of 5, so if we have, for example, 6 or more in the degree, then we simply refer to it as the 6th degree, 7th degree, and so on. No more special names. Make sure this chart is completely copied before we move on. Now we're going to get into some examples of where we use this. Again, you could also take your homework from last night and use this as well. So the first thing it asks us to do is to write the polynomial in standard form, which is again based on the exponents from highest to lowest. and then we're going to classify each polynomial by degree and number of terms. So there are 3 parts to this problem. So our first one, we look within the problem for our highest exponent, which is a 2. So that's going to come first. So we start rewriting 9x squared plus 3x is the next one because it has an x, and then plus 5. Your numbers will always come last because they have a degree of 0. In order to have a degree, it has to have a variable with it. Well, when we classify it by degree, we look on the highest one, which is a 2. Well, degree of 2, if you look back at your chart, that is a quadratic. I then count how many terms there are. So here's one, here's the second term, and here's the third. Remember, your plus and minus signs are what separates them. So since I have 3 terms, we have a quadratic trinomial. Going over to the next example, we've got a bigger problem here. So we first start by looking at our highest exponent. So I see an x, which means an exponent of 1, an x squared, an x to the 4th. I have another x squared and a negative 12. So keep in mind, since these are both x squareds, before I label them or put them to or classify, I have to combine those like terms. So we'll be putting them together. Well, our highest exponent is that x to the 4th. So that's gone. Then my next highest would be the x squareds. Well, negative 6 plus 10x squared becomes a positive 4x squared. And now they're gone. Then I have that 4x at the beginning, which is positive, so plus. And then negative 12 at the end, so minus 12. Now I can start labeling it after I've combined my like terms. Well, our highest exponent we said was 4. 4 is the one, don't get confused, don't try to call it quadratic. We call it quartic. I have 4 terms left. Well, that's more than 3, and any time we have more than 3 terms, it is simply referred to as a polynomial. Now you're going to try the U-try. Once you've tried it, check with a partner, and then unpause this in order to double check your answer. So for our U-try, the first thing is, again, we're putting it in standard form. So you should have had negative 4x to the 5th plus 2x squared. Just like in the last one, we did run into a pair of like terms. Hopefully you caught that, or your help with your neighbor, you caught it. 3 and 10 combined to make 13. Now we're allowed to classify it, but you can't classify it until all the like terms are combined. So I look for my highest exponent, which is now the 5. Well, 5, again, if you have 5 babies, we call it quintic. And then there are 3 terms. Now that we've combined a pair, so 3 terms we refer to as a trinomial. Before we start taking the notes, we need to make one quick adjustment on these. So what I need you to do is where it says left, I need you to cross that out and put right. And where it says right, I need you to put left. Very important to make this make a little bit more sense. Now keep in mind, on a graph, when we talk about right side and left side, on whatever we sketch, this is your right side, and this is your left side. Okay, so just keep that in mind. Even though we start with right usually, again, on a graph, the right side is over to the side, and we would usually do that second, but when we talk about the functions, we start with the right side when we describe them. On your right side on a graph, because any polynomial function is just going to create a graph. We dealt with linear polynomial functions in chapter 1, which formed a line. We dealt with quadratic polynomial functions in chapter 2, which was your parabolas, either up or down. And also back in chapter 1, we also did cubics. If you look at your 1-2 parent function notes, we did graph what a cubic function would look like. Well, your right side, what it could do is it could either go up or down. Well, in order to know if that right side goes up or down, you look where there's a negative, and we're going to talk about the negative lead coefficient. Well, think about it. If you have negative people in your life, what happens when you have negative people? They bring you right down. So if your lead coefficient is negative, the right side will always be down. Well, we don't just have a right side to a function, we also have a left side. So your left side, again, it could either go up or down. To determine if your left side goes up or down, it's not based on the lead coefficient, it's based on your exponent. So if you have an odd exponent, so we're talking about numbers like 1, 3, 5, 7, and so on, then it's the opposite. And just to help us out a little bit here underneath this, I'm going to write if you have an even means the same. Odd is opposite, even is the same. So double check you have this written before we move on to the 2 examples and then the you try. So if I look at my first example, I have the highest degree is the first thing I look for. The highest degree is a 3. So my leading coefficient that's attached to it, my LC, is 4. And my exponent is 3. Well, since my leading coefficient is positive, that means the right side is not going to go down because it only goes down if that leading coefficient's a negative. So my right side goes up. Now for my left side, we base it off of the exponent. Since our exponent is 3, 3 is an odd number, which means we do the opposite. So since the right side went up, that means the left side would have ended up going down. And again, we'll show you some visual pictures here in just a second. Going over to our middle example, we look through the whole problem to find our highest exponent, which is 4. So our leading coefficient is attached to that. This time it's -2. And the exponent that goes with that, our degree, is 4. Well, I look at my leading coefficient, it's negative. Negative people in your life bring you right down. So I know my right side is going to go down. Now I have to determine my left side. So my left side, I refer to the exponent. 4 is an even number, that means that it would be doing the same as the right side, so that means it would be going down as well. Take a moment to do the U-try. Before you unpause it, check with your neighbor and see if you got the same answer, or compare answers to figure out who was right and who was wrong. Well, hopefully we're going to be 100% on this question. We look for the highest exponent. It doesn't always have to come first. Remember that. You do need to look through the whole thing. So our exponent is 3, and along with that exponent, our leading coefficient is a -4. So leading coefficient's a -4, exponent's 3. Our leading coefficient tells us about our right side. So since it's negative, the right side is going to go down. I then use my exponent to determine my left side. Well, exponent of 3 is the opposite, so since the right side went down, the left side goes up. Here are some quick visual pictures of what end behavior looks like when sketching these polynomial functions. Remember, we have an even degree or an odd degree. Even means they go in the same direction. Odd means that they go in opposite directions, which we have on our chart. So if it's positive for a leading coefficient and it's even, the exponent, then both sides go up. If it's an odd degree in positive, the upside would go right, and the down would then have to go, the left would have to go down. If your leading coefficient is negative, which is like the U-try, and they have an even degree, they both go down. If it's an odd degree, the right goes down and the left goes up. So here's some pictures of what both sides would look like if they're going up or down. There's that parabola from chapter 2. Here we have some odd exponents, our cubics, which again you could look back at 1-2. Since it was positive, that means the right side is going up and the left side is going down. This one had a negative, so the right side goes down and the left side goes up. We're not sketching them yet. For homework, you're just telling me if the right side and left side would go up or down.